Okay, so next we'll discuss the T invariant. Okay, now a vector y, which is a solution of this w dot y is equal to 0, is also known as T invariant. Okay, and again y is the firing matrix. Okay, which is multiplied with this w, and if we get a 0 null matrix, right, then y is called the T invariant, right? Okay, the T invariant of Petri net is the T invariant of the dual of Petri net. Okay, now this is a new property. Okay, so if you want to compute the T invariant of the Petri net, right? So you just compute the P invariant of that the dual of that Petri net. Okay, the P invariant of the dual of that Petri net. Okay, now this is something new for you. What is the dual of a Petri net, right? So the dual of a Petri net is actually in linear algebra. You take the transpose of the W, it is the incidence matrix, that will be the dual of a Petri net. WT will be the dual of Petri net. Okay, and you can also compute the dual of a Petri net just by replacing all the places by transitions and all the transitions by places. Okay, and by reversing all the arcs directions. Okay, you will not change the weights of the arcs, you will just change the directions of the arcs, right? So if you see, suppose this is a Petri net right here, with 3 places and 4 transitions. Okay, T1, T2, T3, T4, and 3 places P1, P2, P3. Okay, and we have these arc weights, right? Okay, now to find the dual, okay, you have to replace all the places by transitions. Okay, so this P1 becomes a transition, suppose T1. Okay, this place P2 becomes a transition T2, and then this P3 place becomes transition T3. And now replace all these transitions, 4 transition by places. So this will be place P1. P1 becomes place P1. Okay, and T2 becomes place P2, and T3 becomes place P3. And T4 becomes place P4. And then next step is, the third step is to reverse all the directions of the arcs. Okay, so you see that P1 is connected to P3, so that is why we have a directed arc from P1 to T3. Now there will be a directed arc in the dual Petri net from place P3 to transition T1. Okay, you see here with the same arc weight, right? Okay, and this is how you obtain the dual of a Petri net, right? And this, if you represent this dual Petri net by an incidence matrix, you compute the incidence matrix. So the incidence matrix of this dual will be the transpose of the W of the original Petri net, right? So if the incidence matrix of this original Petri net is W, so what will be the incidence matrix of this dual Petri net? WT. You got that? WT. Okay, so you can compute it graphically or by using the incidence matrix. Okay, now look at this property, the T invariance of the Petri net, of this Petri net. Okay, what is the T invariant of this Petri net? Is actually the T invariant of the dual of Petri net. If you compute the T invariant of this Petri net, it will be actually the T invariant of the original Petri net. Okay, you got the idea?
Yes. Yes.
Okay, and why we do this? Since there is an algorithm, okay, and that algorithm. Hello, can you hear me? Hello. Hello. Hello.
طول ولا سره ما تم مطلب
سنوبي ټول کې کچار لګي
سنو به کې چا له هم سره کنه خو سنو به چې کنده سره هغه کې ډي ډي ال فایل لا کو ما ته ما غاتم کو خو سم فاري هاکي ما ته خوشاله سبیل هم هو او سي
Okay, so now you know how to compute the dual upper Petri net, right? And it's a simple way. Okay, by using incidence matrix, you take the transpose, then that transpose matrix will represent the dual of that Petri net. Okay. Okay, now why we need to compute the dual upper Petri nets, since we have algorithms for the computation of the P invariants. Okay, so the same algorithm can also be used to compute the T invariants. Okay, you got the idea?
Yes, sir.
If we have one algorithm, right? Algorithm which can compute the P invariants of a Petri net. Now, if I ask you the question, how can you use the same algorithm to find the T invariants of a Petri net? Okay, so what should be your answer?
First we have to compute the dual of the given Petri net.
Good.
And then we will find the
P
invariant of the new dual Pn, and we can get the
T invariant. Okay, and that will be actually the T invariants of the original Petri net. Okay, so okay, so here is an example for you. Example 1, example 2, that you can try later on. Okay, right.
Dual.
First, find the dual of these Petri net, the dual Petri nets, right, and then compute the T invariants. Okay, you want to do this exercise now or later on?
Later on, sir.
Okay. Now coming to the let me hide this panel again. Okay, so it is better now. Okay, so here's an exercise. Consider the unmarked Petri net corresponding to this figure. Okay, 2.4. This is an example from your textbook. Intuitively look for the P invariants and T invariants of this net, and then pull the scissors. Given the dual, okay, Pn of this Petri net, what are the P invariants and the T invariants of them? Okay, so let me discuss now the algorithm. Okay. Which can compute the P invariants and which we can also use to find the T invariants. Okay, so adaptation of the algorithm for searching for the T invariants. Okay, so you see that a T invariant actually satisfies this equation xt dot w equal to 0, where w is actually the incidence matrix. Okay, and X is actually the corresponding matrix of the P invariant. Okay, and a T invariant satisfies the equation. Okay, W dot Y equal to 0. Okay, so Y will be then T invariant if this equation is satisfied. In this case, X is T invariant if xt dot w, sorry, X is P invariant if xt dot w equal to 0 is satisfied, right? Okay. Now, first we discuss the algorithm which computes the minimal support P invariants, right? So there are 4 steps in this algorithm: step 1, step 2, step 3, step 4. Step 2 is further divided into 2 steps, 2.1 and 2.2, right? Now coming to the step 1, okay, let A be dimension n unit matrix, okay, where n is the number of places and B is equal to W, okay, B is actually the incidence matrix, okay. Then we construct another matrix, right, by combining, this is actually the combination of the two matrices A and B. A is the unit matrix, okay, right, and B is the incidence matrix. So by combining this, we get another matrix, right, which is called A B matrix, right. And there is a loop now in step 2 of this algorithm, which is repeated how many times? Okay, the number of transitions time, the number of transitions time, right? So suppose we have T1 to Tj transition or Tn transition. Okay, so for each index j of transition Tj, okay, the first step is to add to matrix, okay, AB as many lines I as there are linear combination of two lines, okay, with positive integer coefficient. This is important, right? The new row, a new line that you are going to add to this AB matrix will have positive integer coefficients, right? We cannot add a row with negative coefficient such that there is another condition, okay, that element ij is 0, okay, that is in the jth column, right? The element should be 0. You got the idea?
Yes, sir.
Okay. In step 2.2, okay, we have to eliminate from this matrix AB all the lines, okay, K whose elements Kj, okay, at the same column, jth column, okay, all the elements, all the lines will be removed if at this Kj element is not 0, right? You got the idea? So at the end, you have to do this elimination, okay, in step 2.2. In step 3, let LALB, okay, denote a line L. This is the line L of the matrix AB, the final matrix AB. And PL of A is the support of LA, that is the set of places for which the weight is not 0, okay. If there are two lines P and Q of the matrix such that P of QA is a subset of P of PA, right? This means that P of PA is a superset, right? P of QA, then line P is removed, okay? So P will be then removed. Okay, the minimal support P will correspond to the non-zero lines of A. Finally, you have to pick non-zero lines of A as P invariants, okay, in the final step. Okay. Now, I'll explain this by an example, okay. Now, consider this Petri net, which is the dual of the previous one, okay. I think this is the dual of this one. You see, how many places we have in this case? 3 places.
3 places, 4 transitions.
4 transitions, okay. And the dual? In the
dual, 4 places, 3 transitions.
3 transitions, okay. And you see that the arc weights are also the same, right? Okay, okay. I think it's not the same example, but just consider that we want to compute the P invariance of this one by using the algorithm, okay, right? If now this Petri net is suppose the dual Petri net, okay, again the algorithm will compute the T invariance, and which will be actually the T invariance of the original Petri, right? Got the idea?
Okay. Yes, sir.
Now you see that first we have to construct the AB matrix, okay. So AB is actually the A is the unit matrix, okay, with dimension equal to the number of places, right?
Places.
So we have 4 places. So what will be the dimension of this one? 4 by 4 matrix, unit matrix. So unit matrix represented as 1 0 0 0 for this pattern, 0 1 0 0 0 0 1 0 0 0 0 1, right?
Diagonal के वो ones.
This is also, I think, this is also called the identity matrix, no?
Identity matrix.
Oh, okay. So now, what is this B matrix? It is the incidence matrix, and you know how to write the incidence matrix of a Petri net. So columns are labeled with transition labels. So we have transition T1, T2, T3. Okay, and rows will be labeled with places labels, right? So we have 4 places: P1, P2, P3, P4 in the descending order, right? So now,
for direct incidence
yes, this you can do right by computing, okay, W from the output and input incident matrices, or you can directly write it. Now we will directly write this, right? You know the method. So suppose this is blank, right? Now in T1 column, okay, in T1 column, where is T1 here, right? By firing up T1, okay, how many tokens are removed? Yeah. Okay, in these places, how many tokens are added? You have to write, okay, the corresponding number, okay, in this matrix. So if we fire T1, you see that if we fire T1, it removes one token from it adds token in P1, so we have to write +1 here,
+1,
and it also removes token from P2. Okay. There is no effect of T1 on P3. There is no effect of T1 on P4. So that is why we have 0 0, and that's it. Okay. So now T2, if we fire T2, okay, this is T2, right? What happens? 2 tokens are removed, okay, from P3. So minus, we'll write -2 corresponding to P3, right? You see -2 is here, and 1 token is added in P4. So we have to write +1 corresponding to P4, and since there is no effect of P2 on P1 and P2, you see there is no arc connected to, there is no input or output arcs connected to P1, P2. So just write 0 0, okay, and the corresponding rows. Okay. Now if we fire T3, where is T3? Okay, this is T3, right? What happens? Okay, since T3 is connected to 2 input places, P1, P4, and 1 output place, P2. So now 2 tokens will be removed from this place P1. -2, we have to write -2 here, and -1 here, and +2, okay, P +3 to P2, and then +2, okay, to P3, okay, and that's it, right? So this is, now you see that the computation of the incidence matrix is very easy, right? By just considering the firing rules, right? If you fire and then write down in the matrix the number of tokens that will be removed, or the number of tokens which will be added in the corresponding places, right? As weights of this matrix. Got the idea? So the step 1 is now, in the step 1 we have to compute the AB matrix, which is done.
AB matrix,
right? Which is the combination of A, that is the
B plus
the unit matrix, and B, which is the incidence matrix.
Incident.
Now we have to perform this loop in step 2. How many times? The number of transitions time, right? How many transitions? We have 3 transitions, okay? So J will be initially 1, then J becomes 2, then 3, okay? You see the index J, okay? So J is initially 1, then in the second execution, j becomes 2. In the third execution, j becomes 3. Right? So this the body of the loop will repeat 3 times, right? Since we have 3 transitions. Okay, and now we'll consider, okay, j is equal to 1. So we are actually at the column 1. Okay, you got the idea? And further we have two steps. Okay, we have to add new lines to this matrix, AB matrix. Okay, with which fulfill, okay, these conditions. Okay, if we have positive integer coefficients, okay, in the linear combination, and the element ij is 0. Element ij is 0. So you will make actually linear combination of 2 lines, okay, and if these 2 conditions are fulfilled, then we will add this linear combination as a line to AB. This means that keep in mind that we have to add new lines or new rows to AB matrices, right? AB matrix. Okay, and now so we are here. Okay, for j is equal to 1, right? So the first row. Okay, look at this row, and you have to add. Okay, you have to add this with other rows of the matrix. The matrix is AB matrix is up to this row, okay, and now add this row with other rows of the matrix, okay. If you have suppose a new line with non-negative coefficients, and we have 0 in this ij, right, ij position, then we will add the row, otherwise we will reject the new line, new row, right? So if we add suppose these two, right, so you see that +1 -1 becomes 0, 0 0 -2 +3, which is +1, right? So you see that at this at the first column we have 0, and the other coefficients are also positive. Okay, so we can add this row, right? So you see that p1 plus p2 is added here. So just add this row p1 with p2. So 1 plus 0 1, 0 plus 1 1, 0 plus 0 0, 0 plus 0 0, and +1 -1, it is 0. This is the first condition which is satisfied, right? And 0 and -2 plus 3. So you see that all the coefficients are positive, and we have 0 at this position. So this row is added, this new line is added. Okay, just look at the condition again. Add to matrix AB as many lines I as there are linear combinations of 2 lines, okay, with positive integer coefficients such that element ij is 0. Okay, so for first column this will be I1. Got the idea? Okay, so now you see that here this row is 0, so we can add it, and the remaining coefficients are positive. You got the idea? So similarly, if we add p1 with p3, okay, we cannot add this as a new row, a new line. Why? Because we have negative coefficients, -2 is here, right? And we have also the second condition is not satisfied since we have 1 here, right? Okay. Similarly, if we add p1 with p4 row, again we'll have negative coefficient. We cannot add this. And if we want to add p2, okay, with p3 we cannot add this, right? With p4 we cannot do this. P3 p4 if you want to add this, we have 0, so one condition is satisfied. And let's see, but the other condition, that is positive coefficient, is not satisfied, right? The condition of positive coefficients is failed, right? So we cannot add this. So now this step 2.1 is complete. Now we have to look at this one, right? We have to compute, we have to do some processing, that is elimination from matrix AB all the lines K whose element Kj is not 0, right? So at the end of the first iteration, you have to do some sort of elimination, okay? So look at, since J is 1, okay, so look at 1, 1, 2, 1, 3, 1, and so on. If there is non-negative, if there is suppose non-zero element, just delete that row, okay? Look at, so now you see that here we have +1, okay, at 1, 1, which is non-zero, so we have deleted, you have to delete this row. So you see that this row is deleted, okay? Next, here again we have non-zero element, so we have to delete this row, okay? We cannot delete this row because it is 0. We cannot delete this P4 row because it is 0, okay? You got the idea? So the new matrix is now P3, P4, and P1 plus P2, okay? We have 3, okay? Now in the second iteration, okay, J becomes 2. Can you hear me? Hello?
Yes, sir. Yes, sir.
So now J becomes, now this is in the second iteration, J is equal to 2. So now you have to look at 1, 2, 2, 2, 2, 2, 3, and now again repeat the first step of the this iteration, okay? Make linear combinations, okay? Now in the second column, okay, the element should be 0 and the remaining coefficients should be positive, okay? So if we add P3, P4, you see that this combination doesn't work, but if we multiply P4 with 2 and then add it with P3, okay, so what will happen? -2 plus 2 becomes 0, plus 2 minus 2 becomes 0, okay? So you see that we will have a row 0, 0, here 1, 0 plus 2, 2, okay, and this becomes 0, 0, so here we have 0, right? And this one is also 0, which is non-negative, okay? So all the coefficients are positive, and we have 0 at the second column, right? So this row can be added, this line can be added, and 0, 0, 1, 2, 0, 0, right? So we have no other combination. Next step, okay, what you will do, you have to do some sort of deletions, right? And deletion, okay, is there any, okay, which is the second step, eliminate from matrix AB all the lines K, okay, whose element Kj is not 0. I think there is no such row, right, which can be eliminated. Is there any row? Eliminate from matrix AB all the lines K whose elements Kj is not 0. Okay, so I think yeah, you're right. This one will be deleted, P3, since this is not 0, right? This one is also not 0, so delete this one, okay, and then we will have J is equal to 3. That is the final iteration. In the final iteration, you have to make combinations, okay, of 2 rows, right? Linear combination of 2 rows such that at I, J, we have 0 and the remaining coefficients are positive. Okay, so can we make such combinations? Okay, we cannot do, right? Because we have we have one row which is P1 plus P2 and another row is P3 plus 2 P4. Okay, so we can, if you want to add these two, so we cannot get 0, right? Okay, so we cannot add any further line, okay, to this matrix. And next step is to remove, okay, those lines, right, where we have ij0. So you see that ij, since j is equal to 3, sorry, ij is not 0. Okay, so you see that for this one, okay, this is plus 1, right? For this row P1, P2, ij is not 0, and this row will be deleted. And finally, we have one row, okay, right, which is left. So the iteration stops, okay, here, all the iteration stops, and then we will be in the next step of the algorithm, okay. So let LALB denote a line L of the matrix, and PLA the support of LA, that is set of places for which the weight is not 0, right? So if there are two lines P and Q of the matrix such that, okay, this is a superset of, okay, P of P is a superset of P of QA, then line P is removed, okay. So this condition is not true in this case, right? So we cannot remove this line, okay. And finally, in the fourth step, the minimal support P invariants correspond to the non-zero lines of A, okay. So this is actually the non-zero line of this AB, right? And this represents the minimal P invariant. This represents the minimal P invariant. That is, the minimal P invariant in this case is M1. Sorry, this is corresponding to P3. So this is M3 plus 2 M4, right? M3 plus 2 M4, right? And the corresponding conservative component is the set of places P3, P4, right? You got the idea? Okay, and this is actually the T invariant in the original Petri net, right? If you consider this Petri net as a dual Petri nets, okay, for which this is the P invariant P2 plus P3 plus 2 P4, then what will be the T invariant of the original Petri net? It will be T3, okay, and T4, right? T3 and T4, right? You got the T4 is actually fired 2 times, right? In the original. Any questions so far?
سر په دې موږ ځان بیا دغه وکړو خو دا لاندې چې کوم دوه لاینز ایډ شو دغه سټپ نمبر 2.1 او 2.2 دی کنه سر
جی دا فائنل سټپ چې دی کنه پای کې بیا ریموول لازم خو چونکې موږ مزید روز نشو ایډ کولای کنډیشن نه فولفل کیږي ٹھیک شو نو دا رو چې پاتې شو دا زموږ سره ریپرزینټ کوي مینیمل سپورټ کی انویرینټ ریپرزینټ کوي ٹھیک شو کنه او چونکې دا د دې پیټری نیټ لپاره دی او که فرض کړه دا پیټری نیټ ډولي یو بل پیټری نیټ نو دا پی انویرینټ په د هغه پیټری نیټ لپاره څه شي ټي انویرینټ ٹھیک شو په دې باندې به تاسو ایکسرسایز وکړئ بلکې تاسو دا ټرای کړئ دا ایگزامپل
سر دا موږ د سټپ نمبر 2 په ګل ګران دی اصل کې دا تاسو چې کوم
دا پیټری نیټ په والی کنه دا یو ایگزامپل صحیح ده دا به ټرای کړئ ٹھیک نه just try this one okay and find the T invariants okay of this Petri nets, right? You can use the same algorithm to find the P invariants, right? This will be the dual of the original Petri net, right? The tricoi was a tricoi.
سر پرې دا سټیپس نه دي سره دا په دې کې به مین تاسو یو کالم باندې ډېره خبره وکړه
جی
مخکې سر دا دیس کې سر
جی کوم یو کالم باندې
سر د تاسو چې 2.1 کوو کنه سر نو دا T1 دغه
د T1 لپاره به دا کالم وي ټیک شو کنه د T2 لپاره به دا کالم وي سیکنډ کالم T3 د J چې کله 3 نو دا T3 کالم بوله صحیح
3 پیر به ایټریشنز کی
او 3 times به کیږي دا وجه ده چې we have 3 transitions صحیح او په اولنی کې به کم یو تاسو پوزیشن کنسیډر کوئ کم یو چې هغه 0 راشي کنه هغه به صحیح فرست کالم چې په فرست کالم کې 0 راشي بیا په دویمه ایټریشن کې تاسو ګورئ چې په سیکنډ کالم کې تاسو سره د کمبینیشنز نه 0 راځي او دویم کنډیشن هم سټیسفای کوي کنډیشن څه دی چې باقي زموږ سره کوافیشنټس په پوزټیو ٹھیک ہے نا نان نیگیټیو ٹھیک شو دا څه به وایي چې نان نیگیټیو ٹھیک ده نو که تاسو وګورئ موږ چې کله P1 P2 ایډ کوو T1 کنه یا for j is equal to 1 صحیح ده نو دلته زموږ سره 0 راځي ٹھیک ده څه راځي 0 راځي او ٹھیک شو او دلته هم 0 راغی دلته چې کله موږ ایډیشن وکړو +1 راغی دلته چې وکړو 0 شو 1 1 ٹھیک شو او د رائټ سایډ ته که تاسو وګورئ د دې میټرکس A B نو زموږ سره ټول کوافیشنټس زموږ سره څه دي
پوزټیو
نان نیگیټیو او یو نان نیگیټیو پکار دی بل چې که فرض که کوم ایټریشن تاسو کنسیډر کوئ کنه T1 نو پکار دی چې په دې پوزیشن باندې هم سره چې دا روټیټ کی دا 0 ښه د سره T2
د دریو لپاره
بیا بدلتي 0 پکار J is equal to 3 لپاره بدلتي 0 پکار او دا نور کنډیشن دا به هم چک کوئ خو سره جی
صحیح شو T1 لپاره به داسې وګورو چې لکه P1 P2 ایډ کو که P2 P3 ایډ کو که P1 P3 چې لکه زیروز په دغه کالم باندې زیروز پکار دی او نان نیگیټیو نور
اوس دلته یو کمبینیشن وایم کنه P1 رو والی او P3 رو والی ٹھیک شو can we add these two rows ٹھیک شو نو دا غي ګوره چې کله P1 او P3 ته اډ کې نو زموږ سره بدلتي سره شي +1 او 0 سره شي +1 به راشي کنه
1 مرشي
یو خو دا کنډیشن پکار جلدی 0 پکارو نو دا فیل کیږي بیا بل لدین علاوه د 0 -2 نو بسره شي -2 نو دا نان نیگیټیو ٹھیک شو دا موږ نشو ایډ کولای سره دا کمبینیشن موږ نشو ایډ کولای دا P2 او P2 چې دا P1 + P2 چې دا
سوټیبل
نه کنډیشنز دې فولفل کیږي نو دا رو موږ ایډ کړی دی بیا په فائنلی تاسو په یو سټپ کې موږ دا P3 + 2 P4 دا کمبینیشن هم ایډ کړی دی دا یو وجه ده چې دا ټول وګورئ نان نیگیټیو دي او دلته په J2 دی نو دلته 0 راغی کنه صحیح ده یو دا ایډیشن هم دی خو چې کله تاسو ایډیشن وکئ نو په هغه ایټریشن کې په اند کې به ډیلیشن هم کوئ ها میټریسز نه بس روز داسې ډیلیټ کوئ پریویس روز چې کوم دي ٹھیک ده کنه چې هغه نیوی روز نه چې کوم ځای کې زموږ سره صحیح په دغه جیت پوزیشن باندې ٹھیک شو نان زیرو element C like was the +1 -1 دا روم delete شوی دا روم delete شوی دا وجه ده چې for j is equal to 1 په end کې بیا د elimination لپاره دا یو candidate رو ده چې دا هم ده
دغه سټپ 2.2 دی سره دا
2.2 دی بالکل مثلا 2.2 صحیح نو تاسو چې ایکسرسایز بدیو کوي کنه بدی Petri Net باندې بدیو باندې به خپل شي ها تاسو لپاره یو اساینمنت شو ها ٹھیک ہے تاسو به یو دا الګوریتم ډایرکټ د دې پی انویرینټس معلوم کړئ ٹھیک شو
سر دا په ډول ډول ته به کنورټ کوو کنه دا یو
نو د پی که تاسو د دې پی انویرینټس کمپیوټ کوئ نو بیا به ډول ته ضرورت نه راځي ٹھیک شو که تاسو
د دې یو
که کوېسچن داسې چې فایند دی پی انویرینټس اف دس پیټرن نو بیا به ډول ته کنورټ کوئ نو دا ډول چې تاسو د الګوریتم کین اونلی فایند د پی انویرینټس رائټ او ټي انویرینټس نه فایند کوي صحیح
ها
او که فرض کړه ټي انویرینټس کمپیوټ کوم نو زه بیا هغه الګوریتم لا انپوټ سور کوم ډول ورکوم ٹھیک ده او که فرض کړه زه ډایرکټ پی انویرینټس ته کمپیوټ کوم نو زه به له اوریجنل پیټرن نیټ ورکوم ٹھیک شو یعنی ډبلیو بول ورکوم ٹھیک شو که فرض کړه زه د ټي انویرینټس کمپیوټ کوم نو الګوریتم له ډبلیو ټي ورکوم ٹھیک ده
اثر په دې کیس کې وبه مونږ یو دغه اخلو کنه د ای بي چې اخلو یو به یونټ میټرکس والو یو به انسټنټ میټرکس والو او بیا به سره د سټیپ 2.1 او 2
که د دې الګوریتم ته ټي انویرینټس کمپیوټ کړي نو بیا به ډبلیو ټي علي او که پی انویرینټس کمپیوټ کړي نو بیا به ډبلیو علي د دې پیټرن
صحیح شو صحیح
اوکے نیکسٹ any question
الکان
دا باقي سټوډنټس یې نو دوسه جواب نه راکوي چې څنګه پوه شو که نه
سر سټډي به وکړو نو بیا به انشاءالله ډېر بلد
دا ایکسرسایز به وکړئ ښه
ایکسرسایز د الګوریتم نور سټیپس پاتې شو سره هغه به
نه ټول سټیپس وشول که نه
ها 3 سټیپ 3 به کیو
سټیپ 3 خو موږ اپلای کوو نو پای کې زموږ نور مزید روز نه ډیلیټ کیږي صحیح ده دا کنډیشن چې ګل نه ټرو کیږي صحیح ده او P4 کې خو موږ دا لاست رو چې کوم نان زیرو روز دي دا به کنسیډر کوو د څه لپاره د پی انویرینټس لپاره ٹھیک ده کنه نو دا زموږ سره پی انویرینټ کمپیوټ شو ٹھیک ده
لاست کوم راغی دا پی انویرینټ شو سر
دا پی انویرینټ شو ٹھیک ده نو که فرض کوو دا ډولي ٹھیک ده دا بی چې دی که دا ډولي یعنې ډبلیو ټي نو دا به بیا د اوریجنل پیټرن نیټ لپاره ټي انویرینټ کمپیوټ شي صحیح ده مخکې ځم
او سر دې لپاره 2 کې ملټیپلیکیشن چې ورکړی دی P3 + 2 P4
دا کمبینیشن تاسو جوړولی شئ ها کمبینیشن تاسو جوړولی شئ لکه فار ایگزامپل تاسو P1 وایي چې
میټرکس اپریشنز کولی شو میټرکس اپریشنز
یس اپریشنز پې کولی شئ ٹھیک ده مخکې ځم
تاسو څنګه وایئ سر
که نه تاسو وایئ چې دې پوره دی او څه ایکسرسایزز کوئ